All right. So hello everyone. This is a continuation of the last class. Today we'll be looking into CSEC chemistry. To look into CSEC chemistry, and for all the chemistry students out there, last class we did cover off osmosis, and for today we'll be looking into the three states of matter. And for this class, you can sit, you could sleep, you could relax, and just hear it. Pick up your cup of coffee and take out your chemistry books and pens, and you will be ready to start. So let's begin this class by going into the three states of matter. You have learned already in three states, namely solid, liquid, and gas. The three states of matter have noticeable differences in their physical properties. And you might ask the question, what is physical properties? Physical properties are characteristics that can be observed or measured without changing the chemical composition of a substance. Shape, volume, density, compressibility, solubility, melting point, and boiling point are all examples of physical properties. And we mean physical properties are characteristics that can be observed or measured. So these mean that they're definite characteristics to a solid, liquid, or gas that cannot be changed. It will only be changed through process of melting, evaporation, and these things like that. The different physical properties of the three states can be explained by the particulate theory of matter. And if you have not watched the video on the particulate theory of matter, please go back and watch that video and come back to this video. So let's go into this. We use the arrangement of particles in the three states of matter to explain the physical properties of the different states. Now, point number one, solids have a fixed shape because their particles are arranged in a regular way and they are unable to move out of their fixed position. The second point is solids have a fixed volume and are very difficult to compress because these particles are packed very closely or condensely together and cannot be pushed any closer together. They're already compact. So liquids flow because their particles are able to move past each other. The fourth point is liquids can be compressed slightly because their particles have smaller spaces between them, enabling them to be pushed closer together. Gases take the shape and volume of the container they are in because the particles are moved freely and rapidly. Uh, they only have they have only weak forces of attraction between them. Therefore, they spread out to fill any available space. So between solid and liquid and gas, the particles are within gases are the most spread out and they move freely and they move rapidly. So gases are easy to compress because their particles have large spaces between them. Therefore, they can be pushed closer together. So from looking at this graph, at least, let me see, 10 seconds or could pause the video right here and take a look at the graph. I will go slowly so you could pause the video and take a look at the graph. So moving on, we're looking into the change in state. Change in states. So before we go into the change in states, let's look into the interesting fact of the day. Yeah, circle off right here. I don't like how that is. Circle off right here. Put this in red. This is an interesting fact. I never know what come and see, guys. So as much as this might seem not important, you never know. So that's rated. So it says here, scuba divers make use of the fact that gases are very easily to compress. An average size scuba diving tank holds about 2,250 liters of compressed air. To understand this, think of a milk cartoon. Most milk cartons hold 1 liter of milk. Therefore, a scuba diver holds the same volume of air as 2,250 empty milk cartons. So change in state. Matter can be changed from one state to another state by heating or cooling. A change of state is therefore caused by a change in temperature and consequently a change in the kinetic energy of the particles. For example, in order to change water into ice, we need to put the water into the freezer. i.e., we need to remove heat energy. Changing the state of a substance without changing its chemical composition is a physical change. The different changes of states are summarized in figure or this figure right here. So, what, for example, so we have liquid, right? If you boil liquid, it turns into gas, and if gas is condensed, it becomes liquid. And if you look right here, put this here. No, not that. Um, if a liquid is freeze, it becomes solid. So so we have solid or liquid to solid, and we have if a solid is the solid is heated. If you add heat to liquid, it becomes if you add heat to a solid, it becomes a liquid. And if we draw that right here, yes, right here. Yeah, yes, that'll work. So we'll continue sublimation in another class. So let us look at some interesting fact of the day. So states of matter, on same still on the topic of states of matter, it says melting. When a solid is heated, the particles gain kinetic energy and begin to vibrate more vigorously. Eventually, the particles are able to overcome the strong forces of attraction between them, and they move more freely and further apart, forming a liquid, i.e., the solids melt. The temperature remains constant while the solid is melting because all the heat energy being supplied is used to overcome the forces of attraction between the solid particles. This constant temperature is known as the melting point. Every single solid, at least every single solid, has a melting point, and that is important to note. Evaporation. When a liquid is heated, the particles gain kinetic energy and move faster. Some of the particles near the surface of the liquid have enough kinetic energy to overcome the force of attraction between them and are able to leave the liquid and become a vapor. These particles are said to evaporate. The particles that leave the liquid take lots of energy with them, leading to a cooling of the liquid and then boiling. So boiling is very much self-explanatory. It's not difficult. So it's going to be boiling. When a liquid is heated, its temperature eventually reaches a certain point when it starts to boil. At this point, the liquid particles have gained enough kinetic energy and started to move fast enough to change into a gas both within the liquid and at its surface. The temperature remains constant while the liquid is boiling because the heat energy being supplied is used to overcome the force of attraction between the liquid particles. This constant temperature is known as the boiling point. Boiling point differs from evaporation in two main different ways. So we have number one, boiling point or boiling occurs at a specific temperature, whereas evaporation can take place at any temperature. It says boiling takes place throughout the liquid, whereas evaporation takes place only at the surface of the liquid. And we have condensation. When the temperature of a gas is lower, the particles lose kinetic energy and begin to move more slowly. The forces of attraction between the particles become stronger, causing the particles to move closer together, forming a liquid, i.e., the liquid condenses. We have freezing. When the temperature of a liquid is lower, the particles lose kinetic energy and begin to move more slowly. The forces of attraction between the particles become stronger, causing the particles to move even close together, forming a solid, i.e., the liquid freezes. The temperature at which this occurs is called the freezing point. So we have freezing point and we have boiling point. The freezing point of a pure substance has the same value as the melting point. Example, water has a melting point and a freezing point of 0 degrees Celsius. And it says here with a key fact. Freezing point is the constant temperature at which a liquid changes into a solid. Let's go on to sublimation now. Let's change the topic. When the force of attraction between the particles in a solid are weak, the addition of a small amount of heat can cause a solid to change directly into a gas without passing through the liquid state. If the gas is then cooled, it will change directly back to the solid. When a substance changes directly from a solid to a gas or a gas to a solid, it, it is said to sublime. And with that, that finishes off our class, on this class at least, on the three states of matter. Hope you learned something, and stay in tune for more daily uploads. Please, I just get this live stream here to at least 5 likes. I'll do another live stream on chemistry, exploring different topics for the C6 syllabus. And to be particular, the next topic we look to, so you could get out your pens, is heating and code and heating and cooling courses. That will be our next topic for tomorrow. If this video can get to 5 likes before that happens. Thank you. Please subscribe to the Study Prep Guys channel. We're hoping to get to 1K subscribers, and with the help of you guys, I believe it is possible. So good luck and stay healthy, stay in tune, stay fit, and be ready for Chemistry CSEC 2025. Good luck.